Have you ever wondered how AI seems to know everything? You see these super smart robots and assistants, and you think, wow, they must have all the answers. They can write poetry, create amazing art, and even beat grandmasters at chess. It really looks like they're geniuses, right? But here's a little secret. They're not quite as smart as they look. In fact, a lot of the time what AI is doing is just making a really good guess. Think about it like this. When you were a little kid, how did you learn what a dog is? Your parents probably pointed at a furry four-legged animal and said, "Look, a dog." Then you saw another one, maybe a different color or size, and they said, "That's a dog too." After seeing a bunch of different dogs, big ones, small ones, fluffy ones, short-haired ones, your brain started to build a pattern. You learned the general idea of a dog: 4 legs, a tail, fur, floppy ears, a wet nose. So, the next time you saw a creature that fit that pattern, you could confidently say, "Hey, that's a dog." You weren't born knowing what a dog was. You learned it from examples. Well, AI learns in almost the exact same way. It doesn't inherently know anything. We have to teach it. And how do we do that? We show it a massive number of examples. If we want an AI to learn how to identify a dog, we don't just show it one picture. We show it millions of pictures of dogs. We feed it images of golden retrievers, poodles, dachshunds, German shepherds, and every breed you can imagine. We show it dogs sitting, running, sleeping, and playing fetch. For each and every one of those pictures, we tell the AI, this is a dog. The AI analyzes all these images, looks for common patterns and features, and starts to build its own complex digital idea of what makes a dog a dog. It's not thinking or understanding in the way we do. It's just recognizing statistical patterns in the data it's been given. So when you show it a new picture, it compares that picture to the patterns it has learned and makes a prediction, or a guess. Based on the millions of examples I've seen, this has a 98% probability of being a dog. It's all about probability and pattern matching, not true understanding. This is why the data we feed AI is so incredibly important. The AI is only as good as the information it learns from. If we only showed an AI pictures of big brown dogs, it might get confused if it suddenly saw a tiny white chihuahua. It might think, this doesn't fit the pattern I learned. It's too small and the wrong color. Maybe it's not a dog. This is where things can get a little tricky and sometimes pretty funny. Imagine you show an AI a picture of a muffin and a chihuahua. They can look surprisingly similar, right? Those big eyes, the rounded shape. An AI that hasn't seen enough distinct examples of both might easily get them mixed up. It might look at a blueberry muffin and confidently declare, "That's a chihuahua." This happens all the time in the world of AI development. We see AIs misidentifying objects because of weird lighting, strange angles, or because something just looks a little different. Have you ever seen one of those cats that has markings that make it look like it has eyebrows, or a potato that looks exactly like a seal? A human can usually laugh and say, "Wow, that looks like a seal, but I know it's a potato." We use context and our broader understanding of the world, but an AI doesn't have that. It only has the data it was trained on. So if it sees something that perfectly matches the seal pattern it learned, it might just go with it, even if it's sitting in a bag of groceries. This is the key thing to remember. AI can be wrong. And it's not because it's being dumb or trying to trick you. It's because it encounters something that falls outside the patterns it was taught. It's like a student who has only studied for a specific set of questions on a test. If the teacher throws in a surprise question that looks different, the student might get it wrong, even if they're very smart. The AI is making its best guess based on its studies, but sometimes that guess is just plain wrong. It doesn't have common sense or life experience to fall back on. Its entire world is the data it was trained on. So, how do we make AI smarter and less prone to these kinds of mistakes? The answer is simple. We give it more and better training. We help it learn. When an AI gets something wrong, engineers and developers can use that mistake as a new learning opportunity. They can feed that tricky image back into the system and correct it. They might say, "No AI, this isn't a dog. This is actually a cat that's sitting in a weird way," or "This is a muffin, not a chihuahua." By doing this over and over again, we refine the AI's understanding. We expand its library of patterns. The more diverse and comprehensive the training data is, the better the AI becomes at handling unusual or ambiguous situations. It's a continuous cycle of learning, making mistakes, getting corrected, and then learning some more. Every correction helps it build a more robust and accurate model of the world, or at least the specific part of the world it's designed to understand. This is also why diversity in data is so crucial. If an AI is only trained on data from one part of the world or one group of people, it will be biased and perform poorly for everyone else. For example, if a facial recognition AI is only trained on pictures of people with light skin, it will have a much harder time accurately identifying people with dark skin. It's not because the AI is prejudiced. It's because it was never given the right data to learn from. Making AI fair and effective for everyone means we need to be incredibly thoughtful about the information we give it during its training phase. The more examples it sees, the more situations it's exposed to, the more it learns, and the better and more reliable it gets for all of us. It's a constant process of improvement, so AI isn't magic. It's a powerful tool built on data and patterns. It learns from examples just like we do, and it can definitely make mistakes. But with each mistake comes an opportunity to learn and get better. Now that we know AI learns by guessing and can sometimes be wrong, it raises an interesting question. Can we use this to our advantage? Can we intentionally create things to fool an AI? In our next video, we're going to explore just that. We'll look at how people are creating adversarial examples specifically designed to trick AI systems. It's a fascinating cat and mouse game. Thanks for watching, and don't forget to subscribe so you don't miss it.